Hello everyone, welcome back to another video of an average programmer. Today I'm going to be solving the daily challenge, which is the problem 2583 of LeetCode. This is k largest sum in a binary tree. Let's start with the problem. You're given the root of a binary tree in a positive integer k, right? So if we look up the input parameters, those are the ones. The level sum, this definition, the level sum in the tree is the sum of the values of the nodes that are on the same level. Okay, so what is considered as the same level? For example, in this first example, we have that 8 and 9 are in the same level, right? This is because two nodes are on the same level if they have the same distance from the root. The distance from 0 to 5 is 1, and the distance from 9 to 5 is 1, so they are on the same level. Then we need to return the k largest sum, level sum in the tree. This is not necessarily distinct, so if there are fewer than k levels in the tree, we need to return -1. Okay, so this is a good observation that we need to take in consideration for our edge cases, right? So let's see the first example. We see that we received the root node, and here we have the references to the other nodes. Then we have k equals 2, so this means that we will need to return the second largest sum in a binary tree, and the output is 13. Let's see why this is 13. If we make the level sum for the level 1, we will have 5. If we make the level sum for the second level, we will have 17. For the third level, we're going to be getting 13, and for the last level, 10. So if we sort them, we will have that the first or the largest sum is 17, and the second one is 13. The third one is 10, and the last one is 5, right? So the output is 13. Let's see at the second example. Here we have the reference to the root node, which is 1. It has the left child, which is 2, and 2 has a left child, which is 3, right? We can see that we do not have a right child because here we have null in this part, and we need to return the first or the largest sum, which in this case is 3, right? So this is a really straightforward binary tree problem. So if we want to solve binary trees problems, most of the times we're going to be using recursion. And for this, I'm going to be using DFS. It could be also solved with breadth first search, but I prefer DFS. So I'm going to be using a DFS for traversing the tree. And what I'm thinking right now is that we will need an array for storing the level sums of each level. But we will have to know the level of each node. So if we think about it, we will see that this is the first level, 5 is the first level, and every time that we are traversing down, we will increase the level variable, right? So this is going to be the second level, the third level, and the fourth level. So that could be an approach, using an array and storing the values for each level. Then what would happen if we already have a value in that level? Then we will just need to get the sum and add the value of the level of the node that it's in the same level. So let's consider that. So here we're going to be declaring the variables, which in this case I'm going to be using an array. I'm sorry. It's going to be an array of numbers. And we will need to make a function for traversing the tree. So I'm going to be doing function DFS. What we will need for this, we will need the tree node and the level. In this case, I don't want to return anything, so I'm just going to leave it in void. And what will happen if we do not have anything? We will just return. This is the case for the example 2. If we go to the right node of 1, we will see that we will have null. So we just want to stop in there, right? Right. So then we would need to sum the node value. So if we already have a value for that level, well, let's think about the negative. If we do not have any value for that level, we're just going to be saying that levels in that level is going to be equals to node val. Then if we have a value, we'll consider it as the sum, and it's going to be equals to the levels in that level, and we're going to be adding the node value. So we will not get undefined because we're going to be at this step of the algorithm, the node is going to be existing, so we do not have to worry about undefined, and we just need to set that levels in that level is equal to the sum, right? And then we just need to do the same for the left child, which is going to be node.left, and I'm missing something. I need to increase the level, and I'm going to be doing the same for the right node, and that's all. So now that we have our function, we need to apply the DFS to the root node. So I'm going to be using DFS for the root, and the initial level is going to be 0, right? So that's good. And since we want to get the k largest element, we need to sort them. So I'm going to be using the sort function, and I want to sort them in decreasing order. For doing that in TypeScript is by inserting this in the sort function, and then we only need to return levels in the k-1 because my levels array is 0 indexed, and if this is not defined, we just need to return -1. So this is going to be taking in consideration this edge case, which is if there are fewer than k levels in the tree, we need to return -1, right? So let's see if this works. I'm going to be okay. So as you can see, this is working, I think. So let's submit it and see if there are test cases. Okay, so yeah, as you can see, this is the solution. So hope it was useful for you, and yeah, see you in another video. Bye.